Almost every artificial intelligence you've ever touched, the chatbot, the image maker, the voice that sounds like a friend, traces back to one research paper. 8 people wrote it in 2017, and they gave it a title that was basically a joke. So how did one short paper quietly become the engine underneath all of it? Now hold on to this thread. That same idea didn't stay in chatbots. Before this video ends, I'm going to show you the exact moment it jumped to images, to audio, even to code, all of it running the one trick. Keep score on that promise.
Hi everyone, Nora here. To feel why it mattered, you have to picture the old way. Before 2017, a language model read a sentence strictly in order. One word at a time, left to right, and everything it had read so far got crushed down into a single running memory it dragged forward.
Last time we watched a model get trained on basically the whole internet. Today is the machine that does the actual reading, and why the old machine kept tripping over anything long.
Kai here, and that running memory had a ceiling. Every new word overwrites the summary a little. 20 words in, it's fine. 200 words in, the beginning is basically gone.
Liam here, and my read is that's the whole problem right there. If the answer to your question lived in the first few words, a long sentence could quietly lose it before it ever reached the end.
Exactly the problem, and the fix. The reason we're all here was to stop reading in order at all. Read the entire thing at once. Every word aware of every other word, in a single glance.
And the chat just pushed up the exact thing everyone actually wants to know. It's right there. If this is from 2017, why did AI only blow up around 2022? What took 5 years? Short answer, the idea needed the hardware and the data to catch up to it. Hold that, it's scene 3.
One number tells you it worked. That one paper has been cited more than 250,000 times. 250,000.
I said every word ends up aware of every other word, and I owe you proof. Here's what the machine is actually doing when it reads a line. Here's the move. For every single word, the model asks one small question about every other word. How much do you matter to me right now? That scores the entire trick. It's called attention.
Watch this. Take the sentence. The animal didn't cross the street because it was too tired. When the model reaches the word it scores every other word. The animal lights up bright, roughly 70% of the attention. Too tired is a strong clue, close to a fifth. The street barely registers, around a 10th. That picture is attention.
And the beautiful part, the way I see it, there's no running memory to lose. It's looking at the whole sentence at the same instant, so the distance between it and animal just doesn't...
Say that again. Every word scored against every other word?
Every single one. In a 10-word sentence, that's 100 little glances. Tijursu, 100 glances. And every word does it at the same time, so the word at the end looks back at the word at the start with zero effort. Nothing gets forgotten, because nothing's ever out of view. And that's the reason it beat the old machine flat.
And hold this one for me. Those 8 authors named the whole idea in one 3-word phrase, and that phrase turned into a running joke in the field. Before this video ends, I will tell you what they called it and why nobody can stop repeating it.
Okay, but if it's genuinely looking at everything at once, then reading a whole page should be just as cheap as reading one line. Except that's exactly where it gets expensive because, quick honest ask while we are here. If this has been worth your time so far, hit like, then subscribe and ring the bell. I know everyone asks, but this one is free, and it is how a small channel like this actually grows. Because reading everything at once sounds free, and it absolutely isn't. But here's the payoff first. Reading the whole page in one shot is the single thing that made modern AI possible, and the reason is physical. It comes down to the chips.
Right, sequential just means wait. Word 1, then word 2, then word 3. You can't even start word 2 until word 1 is finished. It's a single file line.
And parallel means all of them at the exact same instant? My read is that's the entire trick. But I want someone who actually builds this stuff. Can we call in help on the hardware?
Let's do it. I've got Dara Ferreira on the line, someone who knows this hardware down to the individual core. Dara, you there?
Right here. And before we start, let me fix one thing. People call transformers just faster than the old networks. Not quite. They're not faster per step. They're parallelizable, which is a bigger, different thing.
Bigger how? Give me the number.
A graphics chip has thousands of small cores that all do simple math at the same time. Feed it one word at a time and almost the whole chip sits idle. Read the whole sentence at once and suddenly every core has work. That's the difference between a jammed road and an open one.
So it's basically a roll call. Everybody answers at the same moment instead of going one by one down the row. I'm calling it the roll call.
Call it what you like. Parallel is the word, but the roll call gets it exactly. Here's a question back for the room though. Why do you think nobody built this in the 1990s?
The chips weren't there yet.
The chips weren't there. The idea and the hardware had to meet in the middle. And once they did, you could train one of these on 8 graphics chips in about 3.5 days, which back then was almost nothing. But you two see the scaling side of this better than I do.
So the upshot is the transformer basically replaced the graphics chip's job. It does the parallel part itself.
Other way around, actually. The transformer doesn't replace the chip. It finally fits the chip. The architecture was shaped to match hardware we already had sitting in gaming computers. That's why it caught fire so fast. Anyway, thanks for pulling me in. I'll let you two run with the rest.
So it didn't win by being clever. It won by fitting the machine.
The idea that fit.
Okay, different animal entirely. One attention layer is impressive, but nobody uses just one. They stack them dozens deep, and what happens when you stack them is genuinely strange.
Stop, because this one splits smart people. When you stack these layers, does the model start to reason or just get better at faking it? Kai says real capability. Nora says watch the word. Kai, make your case.
Look at what each layer actually does. Early layers handle grammar, which word attaches to which. Middle layers handle meaning. Deep layers start handling the task itself, following an instruction, tracking who did what to whom. That isn't one trick repeated. That's a ladder from letters to logic, and it solves problems it was never shown.
Careful, it composes patterns, layer on layer. But composing patterns, the technical word is generalization. Composing patterns isn't the same as understanding them. It's reasoning shaped, and the word shaped is doing a lot of quiet work in that sentence.
Nora, pin it for me. What would the model have to do to move you from shaped to real?
Solve something with a genuinely new structure, not a clever remix of its training data. And honestly, sometimes it does. That's the part that keeps me up.
And the scale is where it gets real. Stack 90 of these layers, each with millions of connections, and you're running billions of these little comparisons per word. Something new shows up at that size that isn't in any single...
That's just memorization at scale. It saw it and echoes it back.
Then explain the parsing result. The original paper tested it on grammar structures it was never trained for, and it still handled them. That isn't echoing.
Fine, the parsing case is real, and that moves me on capability. It doesn't move me 1 inch on the word reasoning.
Here's a case neither of you raised. You keep saying reasoning shaped, Nora. Sit on that word shaped for a second. If the shape is good enough that the answers come out right, does the label even matter to the person using it?
To the user, not at all. To the science, completely.
And that's the ruling. The record is clear on the mechanism. The 2017 paper and everything since shows the layers really do compose, from grammar up to task solving. That part is settled. Whether you call the top of that ladder reasoning is a word choice, not a fact. So the honest verdict. If you're building with it, trust what it reliably does. If you're arguing about what it is, stay humble. You both gave ground, and you're both right about your half, which raises the strangest question in this whole field. If 8 people built this in 2017, who were they, and did they have the faintest idea what they had just done? "8 people, Google researchers. And no, they had no idea.
The paper is called Attention is All You Need, 2017, 8 authors, all listed as equal.
That 3-word phrase I told you to hold? That's it. Attention is all you need. A straight Beatles nod.
And they even randomized who was first author. Here's what gets me. Nobody wanted the credit fight.
And this is this entire design on one page. Remember those 100 glances Liam walked us through? This diagram is just those glances stacked up.
Cited over 250,000 times. That's up with the biggest papers of the whole
Not bad for a paper named after a Beatles song.
of the whole field. And it earned it.
Because quietly it retired the entire old approach. The recurrent networks that read one word at a time, finished, almost overnight.
One page, published in 2017, cited 250,000 times since.
Erica promised you up top that we'd show you where this trick spread. This is it, and I get to be the one who walks you through it. How far did one architecture actually reach? Okay, the payoff I held back at the start. That same attention machine didn't stay in chatbots. Look at the actual word ChatGPT. The G is generative, the P is pre-trained, and the T stands for transformer. It's the same architecture from that one page. Then it jumped. Images fell the day someone realized you can chop a photo into little patches and treat each patch exactly like a word. Audio fell, code fell. One idea, over and over. But there's a bill for reading this way, and that number is coming in a minute.
Watch this fan out. One box at the top, the transformer. Chatbots branch off it. Images branch off it. Patches instead of words. Audio, code, same engine, 4 completely different jobs.
The image one is wild. My read is they literally cut the photo into a grid and feed the squares in like a sentence. A picture is worth 16 by 16 words.
Exactly that. 16 by 16 patches, each one a token. The model never knew the difference between a word and a patch. Attention doesn't care what the tokens are.
Which is why there isn't a special AI built for each thing. It isn't one design per problem. It's one design that eats every...
Timers is Sempers, stop right there, because that's the exact part people miss. Every time you hear that some new AI can do a new thing, images, video, music, it's almost never a brand new invention. It's the same 2017 idea pointed at new data. That's the whole story.
So, as I was saying before Liam grabbed the wheel, it's one design for every job, which honestly should feel less like magic and more like...
Well, then why does it still feel like pure magic to everyone?
Because you never see it happen. Nora, you say this part best.
You see the output, a poem, a picture, a working piece of code, and the one repeated move underneath stays completely invisible. That's the magic. It's just very well hidden.
Hidden and expensive. Nora said there's a cost to looking at every word at once. That bill is the one thing this magic can't hide. Here's the bill. 10 words in a sentence means 100 comparisons. 1,000 words means 1,000,000. That's the price of looking at absolutely everything at once.
Watch the number climb. 10 words, 100 comparisons. 100 words, 10,000. 1,000 words, call it 1,000,000. You square the length every single time. And here's the killer. Double the length, you don't double the work, you quadruple it.
And that one fact explains something you've definitely hit. Every chatbot has a limit on how much it can hold in mind at once, its context window. People ask why the model forgot the top of a long document, and this is the answer. It isn't being lazy. Looking at every word against every other word gets so expensive so fast that at some point it simply can't afford to look any wider. The old networks forgot because their memory faded. This one has perfect memory. But perfect memory has a price tag, and the price grows with the square of the length. Same wall, opposite reason.
And that's the whole frontier right now. Make attention cheaper without making it dumber. Whoever cracks that basically...
So they just add more memory chips and it's solved, right?
Nope, more memory doesn't fix a squared cost. You need a smarter way to look, not a bigger desk.
Okay, but be honest. Is this thing basically maxed out? Have we hit the ceiling on how much it can read?
Two ways to answer that, and the first is a trap. The real question isn't have we hit the ceiling, it's how fast are we moving it? And the answer is fast. What Liam's been calling the roll call gets cheaper every year. So if you keep one line from today, keep this. The limit is real, but it's a moving line, not a wall.
And that price tag is exactly why these things cost real money to run. Which is a whole other video.
But that's the transformer. One idea from 2017. Every word looking at every other word all at once and paying for the privilege. So here's the whole thing in one line. Every AI you use is just a machine that learned to read a sentence the way you do, all at once, deciding what matters and what doesn't.
All at once. Right. And for you, the takeaway is simple. Next time an AI dazzles you, remember there's one repeatable trick under the hood, not a mind. That's power you can see straight through.
Next time we crack open the model itself. A single file of numbers you could, in theory, print out. And it's a lot bigger than you would guess.
I'm still not over the fact that the paper running the entire future has a Beatles pun for a title. Attention is all you need. Come on.
My favorite fact is still the 8 authors, all listed as equal, the order randomized. Nobody grabbed the credit for the biggest idea in the field.
If the transformer makes a bit more sense now than it did 20 minutes ago, do me a favor, tap like and subscribe so the next piece finds you. We're assembling this thing one episode at a time, so here's a question to sit with. If it really is all one idea from 2017, what should we call this era? The age of attention or something else? Drop your answer below. Keep showing up for yourself like you did today. Professor Erica here. Until the next lesson.